last example I want to look at is a square root graph. On this one, we'd like to start off the same way with an XY table. But if we start off the same way with -3, -2, -1, 0, any of those negatives that we plug in aren't going to work. All of those are going to give us not real numbers because we can't take the square root of a negative. So what this tells me as far as graphing is concerned is that my graph's not even going to exist over there on the left side. In fancier terms, this talks about the domain. The domain of this function is only going to be non-negative numbers. It's going to be x's from 0 to infinity. Those are the only x's we're allowed to plug into this function. But if I plug in 0 for x, so I have f of 0, that's the square root of 0. The square root of 0 is 0. The square root of 1 is 1. But if I try to plug in 2, it's not going to be very helpful, because that's going to give me the square root of 2. And I don't really know what the square root of 2 is without a calculator. And so even once I use a calculator at some decimal value, when we're graphing, we kind of want to avoid those decimal values. So instead of picking 1, 2, and 3, I'm going to think about what's the next thing that I know the square root of. And so the next thing I know the square root of is 4, because the square root of 4 is 2. The next thing after that would be 9, because the square root of that is 3. And that gives me enough ordered pairs that I think I kind of know what's going on. That I had 0, 0, 1, 1, I have 4, 2, and I have 9, 3. And this kind of gets me the picture of what's going on. I've got this little curve going on over here. Now notice I do not have an arrow on the left, because again, it doesn't exist to the left. This graph doesn't exist. It starts at 0, 0. That's the first value that I can actually have. And this is our square root graph.